All right, so we seem to have an issue with PDHG where it's not giving us a good answer. For when reconstructing the image, it's basically just giving us back the least squares result. So we're going to try and resolve that. And the way I'm going to try and address it tonight is by um, creating a test for PDHG. I thought I started streaming a little while ago, so I wrote a bit of code without realizing I hadn't gone live yet. So what's happening here, though? We're going to make a matrix A random. We're going to make a vector x by random. And then we're going to find b by just multiplying a times x. Great. And so if we were minimizing the L2 norm of ax minus b, you'd expect to just get back this x, right? But then we're going to add this regularization term, lambda times the L1 norm of x, L1 norm of x. And so that's this problem. We're going to solve it two different ways, with Vista and with PDHG. Vista with line search and with PDHG with line search. And so the issue is that we can't get, to within numerical precision. And sometimes this stuff is just failing. You see, sometimes it fails. With error larger than 1 times 10 to the negative 6, which is the threshold that I'm using to do. So the question is why? Now it could be that there's just an error in the implementation of PDHG with line search. Should we just take a look? So this is the one that I've implemented. PDHG with line search. The iterations are as follows. So x of k plus 1 is prox tau k f, x of k minus tau k a star yk. Is that what we've got? Let's find out. Okay, here's where the iterations begin. This is just calculating the objective values. Here, x is on the first iteration is just the initial guess. Then what do? We take last x. Okay, so now we're just doing this part in the middle. Last x minus tau times A transpose Y. Okay, that seems right. And then if we don't pass in a proximal operator for f, we're assuming f is just the zero function and the proximal operator returns the identity. Okay, so then we get prox of tau f. Prox of x, this input, tau. Yeah, that's the scalar that we're multiplying f by. Yeah, tau, okay. Then set tau equal to here. Last tau is equal to tau. Tau is equal to tau times square root of 1 plus theta. Okay, so we're increasing it as large as we can. Great. Theta naught is equal to 1. Where's theta? Yeah, if we don't supply theta is equal to 1. Great. So while true, theta is equal to tau k plus 1 divided by tau. Theta is equal to tau divided by last tau. Good. X bar is equal to x plus theta. x bar is equal to x plus theta times the difference of x. Where is the difference of x calculated? Diff x is equal to x minus last x. All right. Shoot. And then y is, let's see, prox g. So we're going to create this thing in the input first. Y plus beta, last y. I see last y is equal to y. Last y plus beta times beta tau. Beta times tau. Why did I do that? Because I use it twice. Okay. Beta times tau times a applied to x bar. Okay. And then we're going to do the prox of g conjugate, beta tau of that. That's going to give us y. Okay. That seems right. A conjugate transpose, so A adjoint times the difference of y minus last k. That's because A is linear, so we could factor it out. And this becomes A star yk plus 1 minus yk. So this diff y, A star y minus last y. If theta times the square root of beta, if tau times the square root of beta times the norm of AT diff, okay. So this is going to be the L2 norm. And the L2 norm is the square root of the inner product where did it go? Norm AT diff y, square root of the inner product of AT diff and AT diff. And what is inner product? It's up here. The real product of the dot product, and the dot product, this is the conjugate transpose of B times A. Okay. So that seems right. If that's less than or equal to delta, where the heck is delta? Delta's 0.99. Okay. Times the norm of diff y. Then break. Else tau is equal to mu times tau. And then you do it again. All right, well, there's no obvious, this code looks like a faithful representation of what's written here. It's possible what's written here is wrong. Let's check. Your first order primal dual algorithm with line search. Malitsky and Pock. Wow. Coughing a lot. Okay. Compute x of k minus 1 minus tau of k times k star y. I guess we're now just doing comparing between here and here. X of k minus tau k star y. X of k minus tau k star y. Okay. Prox tk minus 1, tau of k minus 1 g. So they're calling it like g and h or something? No, g and f. Huh. Well, that's an error. Do you see it? That's G. And that's F star. Wait, so which one is what problem are they solving? We gotta look that up. F of kx minus g. So RG is their F and vice versa. Okay, so never mind. That's F for us. Then choose any tau in that and make it as large as possible. Line search, compute that theta is equal to tau k. Theta is equal to tau k plus 1 divided by tau k. X bar is equal to x plus theta k, x minus x last x. X bar is equal to x plus theta k plus 1, x minus last x. Good. Prox beta tau f conjugate. Prox beta tau g conjugate of yk plus beta tau k a x bar. Yk plus beta tau a x bar. Okay. Oops. Break line search if this is true. Square root of beta tau k square root of beta, the norm of k star times yk plus 1 minus yk, the norm of a star yk plus 1 minus yk, because we go to delta times yk plus 1 minus yk. That seems to be what it's doing. Okay. Okay. For whatever reason, Vista and PDHG are this close. That's a bummer. Okay, now F2 is equal to X. So now here, F is, we're not going to supply it. G is going to be all of it. Plus okay. What's the proximal operator of that? Prox L2 square. Is that a function? Yes. X from 1 to nx. It must take prox f. But you could supply nothing. Does this run? No. Arrays have incompatible dimensions. Huh. $185. Wow. Oh. 10 by 1, 7 by 1. How did that happen? All right. A is 7 by 3. X is 3 by 1. So Y should be 7 by 1. Good. Huh. Oh, this is the wrong A now. I'm clearly coughing too much, so I'm about to just call it a day. A is now the concatenation of the matrix A. Apply A is now the concatenation of the matrix A with the identity matrix. That still seems like it's going to give the wrong answer, doesn't it? Oh, no. Okay, why did it break? Too many input arguments. All right. What to do about this? So A needs in and off. I don't think I can define it here. $12.52. Does that work? It works. Undefined function apply A. Huh? What is A? Function handle to apply A. The fact that it's using the same name, is that bad? Apply A. Undefined function apply A. What if I called it like apply K, just to... Surely it's not that, right? Yeah, I didn't think it was. Undefined function apply K for input arguments of type double. What are you talking about? Oh my goodness. Genuinely don't have I don't know the issue. Apply. Okay. This apply A is a function handle. The A is apply A PDHG with line search. Why can't I? Oh Lord. Why can't I go to that? Is it like not so 1, 2, 3? Does PDHG take 1, 2, 3? Yeah. And then A. I'm passing in a function handle. The function handle to this function. Why isn't it working? If I do this, it should give me an error that there aren't enough inputs. Undefined function or variable, apply a PDHG. What on earth? It's like not recognizing this function. I'm defining a function in a function. This should be totally okay. All right. Wow. Now is it totally okay? No, it's not doing anything. Nothing. It's just doing nothing. Okay. That clearly didn't solve it. Unrecognized function or variable. This is not what I thought I was going to be fighting with. I mean, this is ridiculous. It just doesn't see that variable that I'm creating right there. Have incompatible sizes. y is 13. Last y is 10. Y is last y 10. Fly A is A. And A is 10 by 3. That seems right. So y is, wait, A is 10 by 3, right. 7 by 3 and then 3 by 3. So why is that giving an issue? Last y is 10 by 1 and y is 13. Oh my goodness. A. If I solve this bug, we're ending the stream. Oh, failed with error 1. Okay. Again failed with error 1. Okay. So this is nice. This is a very, very simple test. Never calls G. All right. This is outputting zeros. Is there something about this line search? Does it require F? Okay. The constant function is lower semi-continuous, the constant zero function. So leave. This should work. And this is nice. We have a very simple what if A was I? Does that still fail? Please say it fails. Oh, I see. I need an A equal to 3. Excuse me. Okay. Now A is equal to I. So B is just I. X Vista is giving us something reasonable, close to the original. And PDHG with line search is returning darn near zeros. Okay. What is X? X is just last X, whatever the original value is. As far as something reasonable, and Y is going to be numbers. They're numbers. Okay. now XBAR is tiny. I should call this testo. The towels are all, hovering around 1 to 6 or so. They're not going insane to insane numbers. So what on earth is going on? Zeros. It's outputting zeros. This is prox G. So prox G conj 2 is equal to prox G2 in sigma. Oh, now back to this. It doesn't recognize that? Okay. Still fails. We got zeros. Okay. We've got a simple test that we can try to use to debug this thing, which is what we'll do next time. Good night, everyone. Where is it?